So how does microgravity affect us and affect things that we take for granted here on Earth? Well, one of the things that we first understand is in space, in microgravity, there is no up or down. We understand up and down because of where gravity is pulling us to. In the International Space Station, there is no up or down. In fact, they have 4 floors. They have 4 ceilings, 4 walls, however you want to call them. So they can move around and they can have experiments on every wall, every direction that they're working on. That is an excellent thing for them. Astronauts also have explained that they have trouble tasting things. And what happens is when they get into the microgravity environment of the International Space Station, all the fluid in your body tends to kind of centralize itself. You don't have gravity, pulling blood down to your legs. You're not pumping around. Everything just kind of pools around here, and they end up with what they describe as kind of like a stuffy nose. If you've got a cold here on Earth, you kind of have that stuffy nose feeling. Well, that affects their sense of taste because they can no longer smell anything. So they like a lot of really spicy foods so that they can enjoy what they're eating. To me, one of the most interesting effects of microgravity occurs with convection. I love talking to my students about convection. That's one of the standards that we teach a lot of: conduction, convection, and radiation. And we understand convection as the movement of thermal energy through a fluid. As the energy of the molecules increase, the thermal energy increases, they get farther apart, becomes less dense, and it rises because the heavier, more dense, cooler material is going to the bottom, just like the air in this room right now. Well, in space, this doesn't really happen that way. It doesn't really move. Their density doesn't really matter as much. So you take, for instance, a match. Light a match, look at the flame. It's got a nice little cone shape to it. You've got the different colors that appear throughout it. Take a look at this picture. On the left, you'll see a match on Earth. On the right, you will see a flame in space. Now, fire is very, very dangerous in space because you have a high oxygen environment. So in a high oxygen environment like the space station, you do not want any open flame. So these experiments are conducted in an enclosed space. So if you take a look at those pictures on the right, the picture with the blue flame, it's like a ball because that warmer air is not, those molecules are not expanding and going up. So it just expands out in all directions around the flame. This is really cool. I really think this is just a really cool thing. Another thing with convection is how astronauts breathe in space. If you did not have a circulation system, an air conditioning system, a fan of some sort moving, astronauts would eventually asphyxiate from the amount of carbon dioxide they are breathing, because it would come out as you breathe out and it would just sit here. Instead of being warmer as it leaves our body and rising into the atmosphere, and then we bring in the oxygen, you would end up with a bubble of carbon dioxide right here. And that's not good. We also have the same problem with water vapor. As you try to breathe in and breathe out, you expel a lot of water vapor. Luca Parmitano, in one of his spacewalks, had a problem with his spacesuit with the circulation system. And he noticed something on the back of his head kind of bothering him a little bit. Of course, you can't reach back in a suit. You can't reach back and get it. And he radioed down to NASA, and they said, well, let's keep an eye on it, see what's going on. And eventually, what happened was it was water. And so as he was breathing out, there was a problem with the circulation system. It wasn't taking the water vapor back in and storing it. It was gathering up in his helmet and formed on the back of his head, and eventually started moving across the top of his head till it was down over his nose. He almost drowned in his spacesuit in space. He was able to get back in the space station fine, and he has flown since then. But that just goes to show you that you have to be very aware of how convection works in a microgravity environment.